Hello, my name is Christopher Adebumi, and I'm presenting you the review for the T2 Laboratory Inc. Runaway reaction. And I'll start with the introduction and the event scenario of this explosion. And it was on December 19, 2007 at around 1:33 p.m. There was a catastrophic explosion that rocked the north of Jacksonville, Florida, United States. It was a deadly explosion that killed 42 laboratory employees and 32 members of the community were injured. This includes some employees of T2 laboratory also. Nearby buildings were destroyed by overpressure wave and debris found about 1.6 kilometers away from the site. And this explosion was at about 30 kilometers from the explosion site. And also T2 CSB discovered that the explosion was as much as 635 kilograms of TNT. The event of the accident happened at 7:30 a.m. So their T2 production, what they produce is MCNT, and this MCNT involves three processes. On that day of the accident, they were on the first phase, and they couldn't get to the second phase, not the third phase. And at 7:30, they usually start the batch processes, and it was the 175th batch process, and it was done in a 2,450 gallon of reactor. And sodium metal is added in the reactor with methylcyclopentadiene dimer and diethylene glycodimethyl ether, that's the diglyne, which is the solvent. So the heat is then added to melt the sodium metal. When the temperature gets to 300°F, the heat is turned off, but the heat temperature kept rising to about 360°F, and then the operator from the control room discovered that there was a cooling problem because he tried to cool it, but the temperature kept rising. So when it was 1:23 p.m., he sent for the owners of the T2 laboratory. So few minutes later, after the owner came at 1:33 p.m., reactor exploded and killed 4 employees and injured people in the site and around nearby businesses around T2 laboratory. The cause of the explosion is the cause of a runaway reaction with the MCNT process. The process, the controller in the operator in the control room was unable to cool the temperature that came from the exothermic reaction. The exothermic reaction was the runaway reaction was the second exothermic reaction, which is the decomposition of the diglyne solvent. There was also a redundancy in the cooling system design. There was a single design failure. There was no backup to the cooling system. The cooling system was only from the local community water in Jacksonville, and there was no backup to cool down the reactor if there was a possible runaway reaction. And we see here that the pressure relief system was wrongly sized, and we're going to talk about that later on. The possible causes of cooling system failure, there might be that the water supply valve was partially closed, or it failed to open. The water drain failed or was partially open. there was a failure in the pneumatic system to open, close the valve. There was a blockage in the pipe, or there was incorrect reading of the temperature. Maybe it was much higher than it was reading. There was mineral scale buildup in the cooling pipe. Mm. So the owners of T2 Laboratory already have made a lot of bad decisions and poor decisions prior to this accident. One of it was there was no record of hazard analysis when they scaled up from 1 liter gallon, 1 liter reactor to 2,450 gallon of reactor, and there was failure to size the relief device in case of a runaway reaction. So CSB reported that the relief valve was only sized in a normal operation, so they were not considering a runaway reaction location. There was no documentation that supported or showed how the relief valve was sized. There was prior exothermic reaction incident that happened was not properly corrected, and they only just changed some of the reactants used in the process. Both owners neither have reactive chemistry experience, although they had degrees in chemical engineering and in chemistry, but they've never, and they've also worked in the chemical industry, but they've never had to deal with the reactive chemistry. And they were unable to identify the hazard behind the reactivity of their production. And we can see here that inherent safe design is very important during the conceptual period of a design process, and it becomes harder when the project progresses. And there's a lot of opportunities in studying inherent safety from the conceptual period to the flow sheets, and when it gets to the P and ID stage, when it becomes harder, and so on. My recommendation is that contractors should be allowed to be involved in the process design of plants. For instance, when the reactor was constructed, there should be involvement of some contractors to be able to answer questions if something goes on or wrong. And also there should be an alternate route to cooling system. As an analysis should have been performed when designing or when changing the processes. So when scaling up, there should be another performance of hazard. And T2 should have used small batches for safety operations. This will mitigate the amount of explosion that happened that day. And there should be preparation for worst case scenario. My conclusion is that T2 made a very terrible mistake of not performing hazard analysis when scaling up from 1 liter reactor to 2,450 gallon. And also industry should implement management programs to prevent or mitigate the catastrophic accidents. Management programs, they should implement training of operators, periodic training of operators also. Process safety courses is required for to get accredited for chemical engineering or any engineering. It should be required for students, and it should be required for employees and operators in chemical industry. And that's my review for the T2 laboratory explosion. Thanks for listening. And this is my reference.